Let's imagine that we have an inclined plane of angle alpha, and the height here is, let's say, L, and we have an object that is released at the top of the inclined plane, and then it travels on a horizontal surface, and then it goes up another inclined plane of angle beta, and we want to know how far up along this inclined plane it goes. So we want to know what this distance is from here to there. Let's call it x. We want to know what that x is. So we could use kinematic equations, but in one line we can solve this using work equals difference in kinetic energy. And so separately we need to work out the work, and we need to work out the kinetic energy difference. So the kinetic energy difference is the final minus the initial. Now the object reaches the maximum distance along the incline with 0 speed, so the final speed is 0, and therefore the final kinetic energy is 0, because kinetic energy is 1/2 m times the velocity squared. And the initial kinetic energy is 0 as well, because the object starts at rest, and so we release it from there. So the difference in kinetic energy is 0. And now we can separately evaluate the work, and then we'll put it here, set it equal to the difference in kinetic energy, and we can solve for our unknown x. So there are two pieces to the work. There's the work of gravity that speeds the object up down the inclined plane. Along here, the object continues to move and there's no friction, so there's no work being done. And then we have negative work. It's the same force, it's the force of gravity. So it'll have the same form. So what we want to figure out is what is the force of gravity along the inclined plane, and that's mg sine of alpha. That must be the force of gravity down the inclined plane, because that's the quantity that goes to 0 if the inclined plane angle goes to 0, and the force along the inclined plane would have to go to 0 because it would be horizontal, and gravity is not a horizontal force. So that must be the form of the gravitational force, and the work done is this times the length, but the length along the incline here is, I can call it y, but of course y sine of alpha is equal to L, and so y is equal to L over sine of alpha. So I'll put L over sine of alpha. That's the work, but that's equal to mgl. So notice that when it comes to gravity, it doesn't matter that the object is moving partly horizontally in this path. All that matters is the vertical displacement. So it's just gravity times the vertical displacement. And so we have the work as mgl. Of course, we don't know what m is, so that's an unknown quantity. And then over here, it'll have the same form. It'll be the mass times g times this height, written in terms of this quantity here, which is what we want. So it's mgx sine of beta. That's what the vertical displacement is. So we have minus mgx sine beta. And so x is right, we'll bring this to the side. The mg's cancel. We have L divided by sine of beta.